exponent, because remember, we don't want negative exponents anymore when we do these. We want positive exponents. And so far we've ended up with negative exponents, and we want to make sure we write them correctly. What happens when we have a negative exponent? What is the equal, or what does that equate to? And we want to show you here in these notes exactly what they are and what they do. The first things first, to do these things, we have a few definitions we want to go over. Things that you need to know to be able to do these. So the first one here is reciprocal. When I take the reciprocal of something, it's usually a fraction I have like this. Here's my fraction 5/7. So when I take the reciprocal of 5/7, is what happens is the denominator and the numerator, they switch places. And when they switch places, it flips over to become 7/5. And what the reciprocal does is it is a opposite that will equal to 1. So what I mean by that is it's a flip. And when I flip it and I multiply it by the original answer, it equals 1. So in this case, what we're all worried about here in this case is that this is just going to be a flip. And what happens is when you multiply it by the original, it equals 1. Okay? So what I mean by that is, an example here would be 5/7, 5/7. The reciprocal, when I flip it, FLIP, it's going to turn into be 7/5. And when you multiply 7/5 by 5/7, it turns into 1. Such as, here's an example. Here's what happens. 5/7 times 7/5 gives me 35/35, which is 1. Okay. Another example here could be if I have one like this. If I have 1 over, let's say here, y, and I was going to flip it, FLIP, it's going to turn into just y over 1. And the same thing as well, when I take this 1 over y times y over 1, gives me y over y, which is 1. So that's what the reciprocal does. And that's going to help us be able to change the positions of these negative exponents in these cases. Okay? So a negative exponent is this basically an exponent that's negative. That's our second definition. It's simply an exponent that is negative. Such in this case, and what also it does, it makes things smaller. Okay? It makes things smaller. And we'll show you. So here's an example. So a negative exponent is an exponent that is negative. Pretty simple. Okay? It makes smaller. So you're going to get smaller when you have this. Sometimes it can be bigger, but most of the time it's going to be smaller. So an example of this would be if I have n to the negative 5th power. Okay? That is going to be a small in this case. If I have 5 to the negative 2nd power. If I have 2 to the negative 3rd power. Or if I have, let's say here, y to the negative 4th power. Those are all going to be smaller. They all work smaller in that case. They work smaller, and they show you how they are happening, what happens to the flip. Okay? They show you what happens. And what I want to do is, real quick, is just show you why it makes it smaller. You know, why we need to flip these things upside down, what happens, and why we do the reciprocal. Okay? So what I'm going to do is I'm just going to take this, I'm going to put this on the back here real quick. And I'm just going to talk to you about what happens if I take these exponents. 5 to the 0, 5 to the 1st, 5 to the 2nd, 5 to the 3rd. And when I do those, you can see here that I'm going to end up anything to the 0 power is 1. Anything to the 1st power is 5. Anything here, this right here is going to be 25. And 5 to the third power is going to give me 125. Okay? And when I tell you that it's going to be smaller, let me show you. Well, all these exponents right now are positive. All these exponents right here are positive. So all these right now are positive. And you can see that as each time they grow, as they get bigger with the positive, my answer is getting bigger. And what happens is when I went from here, this is 1, what happens is when I went from 0 to 1, I just multiplied by 5. Because 1 times 5 is 5. When I went from 5 to the first power, it was 5, to 5 to the second power, which is 25. It grew by a factor of 5 as well. And you can see the same thing is going to happen here as well. So basically what happens, it doesn't matter how much I get, if I keep going on and on and on forever, and I take 5 to the nth power, it's going to always get bigger. That's when it grows and it's positive. But what happens when I get to 5 to the 0 power, and I want to get to, and I want to know what is 5 to the negative 1 power, or maybe 5 to the negative 2 power. Well, let's see what happens. Okay? So what happens is we got to go in the opposite direction. So what happens if I go in the opposite direction? So if I go from 3 to 2, it gets smaller. You can see that 125 to 25. When I go from 25 to 5, it gets smaller. When I go from 5 to 1, it gets smaller. Well, how much does it get smaller by? Well, what happens is instead of multiplying, when I get bigger here, I multiplied. I do the opposite here, and I'm dividing by 5. And when I divide 1 by 5, I end up writing out my answer to be 1/5. When I divide 1/5 again by 5, it turns out to be that 5 to the negative 2 power is 1 over 25. If I did 5 to the negative 3rd power, I divide 1/25 by 5 again, because it's getting smaller. It turns out to be 1 to the 1/25th power. Well, that's interesting, because all of a sudden now, we can kind of look at these things and try to think, well, what happened there? Well, what happened right here in this stuff right here? Why did all of a sudden it become a fraction? Well, we saw that it became a fraction because we were dividing. We divided by 5. But let's take a look at it a little bit. Let's see if we can find a pattern or two. Okay? 5 to the first power is 5. And 5 to the negative first power is 1/5. Well, could I not say that, change this 1/5 to be, say, 1/5? Could that not be the same as 1 over 5 to the first power? It can't be. So what this happens is, you can see this. I've taken the reciprocal of 5 over negative 1, and I've changed it to 1 over 5 to the first power. Let's look at this one. 1 to the 25th power. Well, what is 25 written as an exponent? 5 to the second power. So basically, it's saying 1 over 25 is the same as 1 over 5 to the second power. And that is the reciprocal of 5 over the negative 2. Because you know, if I wrote that as a fraction, it's this. There's those as a fraction. And so what I did there was I just flipped them over. And that's where the reciprocal comes in. And look, it's positive now. If I take this one, this as a fraction, and I flip that one over, it's going to be 1 over 5 to the third power, which is the same as 1 over 125. And now I've written my exponents as positive right there. And that's basically why we take the reciprocal. That happens to be the reciprocal there. So that's all we're going to do, is if you take a negative exponent and you flip it If you move it from the denominator to the numerator or the numerator to the denominator, the exponent changes sign. So in that case, and that's what we want to add here. So as you can see here, it's at the numerator. We flipped it over to the denominator and it changed sign. Same thing here. We flipped it over from the numerator down to the denominator and it changed sign. So that's what we're doing here as well. So it's an exponent that's negative. It makes things smaller. And when it moves from either the denominator to the numerator or the numerator to the denominator, it changes sign. It will become positive or it can become back negative. So that's what happens there. So that's very important for us to know about what a negative exponent does. And that's why we use the reciprocal. Okay? So a case in point here would be if I were to take these things, and just to kind of give you an example, if I have 1 over 5 to the negative third power, and that is a negative, and that's a no-no. I want it as positive. So what happens is I take the reciprocal, I flip this over, and when I flip him over, the negative 5/3 comes to the top. And he becomes a positive, and the bottom is just flips over to be the 1. So there's that one, and there's the reciprocal again. Or there's this one, and there's the reciprocal. It just flips back and forth. So if it's in the bottom, it flips to the top and changes the sign. If it is in the top, we'll put an X there. So I want to take the reciprocal of this. I got a negative exponent. I flip it over. What happens? Well, the numerator flips over to the denominator and changes sign. There it is. You can see it right there. It's on the top. This was on the bottom, so they just changed spots, and the exponent becomes positive. Or they're right here, and I flip it over, and they change spots, and the exponent then became negative. So that's basically why we're taking the reciprocal of these things. Okay? So what happens when we do these things, and why does it happen that way? So if I give you a problem here, I don't know, let's see if I end up with an answer here. If I have, let's see here, 6, and I'm going to put in parentheses to the negative third power. Okay, I want to know what is that, 6 to the negative third power. Well, what I need to think about it is, how can I write this as a fraction? So this is basically as a fraction is 6 to the negative third power over 1. Okay, and I can't show an example of this yet because I got to take the reciprocal, the next step. So when I take the reciprocal of it, the 1 becomes the numerator, the denominator is now the 6, and it changes to a positive. And there it is. So I can now expand that out to 1 over 6 times 6 times 6. And when I do 6 times 6 times 6, I'm going to end up with the answer to be 1 over 2. And I believe 6 times 6 is 36. 36 times 6 is 216. So it turns out to be 1 over 216. And that's my answer. And it's in the positive form. Here it is, it's positive. Here it is as the answer. There it is as expanded form. And you see that it's smaller there in this case. Okay? If I give you another one here, let's see here. If I say x to the negative fourth power, and I want to know what is that. So I change this, here it is as a fraction, x over negative 4 to the first power. Okay, it's negative. I don't want it negative. I want it as a positive fraction. So I take the reciprocal of that, and when it does that, because of the math I just showed you on the back side, the numerator jumps to the denominator and becomes positive because it was negative. This jumps up to the top and becomes a 1. So my answer is 1 over x to the fourth. And if I wanted to expand it out, you can see it right here, expand it out, and just in standard form. There it is. Okay. Let's try another one. I don't know. Let's see here. Let's see here. Let's do 2 to the negative third power. And so what happens is I take the exponent. I need to write it as a fraction. It's 2 to the negative 3 over 1. I then take the reciprocal of this bad guy. He flips over and becomes positive. There he is. The 2 negative 3 jumps to the bottom, the 1 jumps to the top, and when he switches sides, he becomes positive. Okay? So what happens now? I got 1 over 2 times 2 times 2, which now becomes 1 over 8. And that's my standard form answer. So that's basically all we're doing, is we're just writing them and we're just changing the signs of where they're at. So if I do this, it works with fractions. If I have, let's say here, 2/3 to the third power, to the negative third power. Okay? Well, it's already a fraction, and I just need to flip this bad guy over. Okay? So I'm ready to flip him over. Ready to flip him over. So what happens when I flip him over? He becomes 3 over 2, and my exponent changes to 3 because it flipped over. It becomes 3, positive. Now I can do my expanded form. There it is. Because this 3 is saying 3 cubed and saying 2 cubed if I want it. And there it is, out for you. And 3 times 3 times 3 is 27. And 2 times 2 times 2 is 8. So I get 27 over 8 in this case. Okay? If I do another one like this, I don't know, say 1/4 raised to the negative 4th power. Okay? So it's taking, this negative 4 is taking the 1 to the negative 4th power. This negative 4 is taking the 4 to the negative 4th power. Okay? It kind of looks like this. If I wanted to rewrite it, it looks like this. There it is. Okay? So this is the same thing right there. And that's what's happening. So now I just do the math because these are negatives. I don't want negatives, so I got to get them positive. So what I do is I take the reciprocal, and when I take the reciprocal of this, it becomes 4 to the 4th power on top and 1 to the 4th power. So there it is. 4 to the 4th power, 1 to the 4th power. The negative is no longer there. Now I just do 4 times 4 times 4, and then 1 times 1 times 1 times 1. And when I do this, I get 16 times 16, which is 196 over 1, which is actually 196. So in this case, my answer did get bigger in this case because it's a fraction. Okay? I'm going to do one more example with you, and then I'm going to let you try some on your own here as well. So what happens here if I take one, let's see here, let's see if I got, let's see here, 5 to the negative 2nd power. Okay? So we'll write this as a fraction, so it'll be 5 over negative 2 to the 1st power. Now it's as a fraction. I now just say, okay, I can't have a negative, so I got to move them down to the denominator, and to do that, I take the reciprocal. It's 1 over 5 to the 2nd power now. It's now positive, so I'm good. It now becomes 1 over 5 times 5, because we expanded it. And 1 over 5 times 5 is 1 over 25. And so there would be my standard solution right there. Okay? So the rule when you do this is simply make it into a fraction. Take the reciprocal. And if you don't remember what the reciprocal was, it's right up here. It's the flip. It's to flip it. And now what that happens that does is when you flip it, it moves the negatives. As you can see here, it moves the negatives and makes them positive. Okay? You're going to keep the base and make the exponent positive. Okay, so that's basically what we're doing. Okay, so if you were to do one like that, that's basically all we're doing. Here, you got this one, 1/2 to the -2 power. It's the same thing as 1, bam. There it is. Take the reciprocal, and take the reciprocal. So I'll flip that over. My reciprocal will then be 2 to the second power, 1 to the second power. And you see it's positive. My exponents are now positive, and then I can do my math from there. And then I end up getting my answer to the first power. And there we go. I end up getting my solution there and answering those questions, and it works out perfectly. Okay? So what I want you to do is on with your notes, you're going to get your organizer. And I know that you're going to say, man, this organizer's got a lot of little things. Well, it does. It's got it all right here for you. And I'm just going to give you 4 exit slips, 4 little problems to do. All you got to do is then ask Mr. O to ask him to check it for you. If you have it checked, then you can go on to your iExcel and move on from there. Because we got to make sure we understand what we're doing here. So the first problem I want us to do is going to be 4 to the -2 power. I want to do the next one here as 6. I should probably put parentheses around here. 6 to the -3 power. I want to do this one as 2/3 to the -2 power. And then 1/5 to the -3 power. Okay? So as you do those problems, remember, change these 2 here into a fraction, just like how we did up here. See how we changed them to a fraction? Take the reciprocal, expand it, bam. Okay? Changed it into a fraction, take the reciprocal, expand it, bam. Same thing when we get right here. So what we have here is we took the reciprocal, poof, expanded it, bam. And these are equal. So the answer you get here is equal to the answer that you have over here. Those are the same thing. Okay? They're the same thing. They mean the exact same thing. All right? So you try these. Let Mr. O check them. If you get checks on them and you're right, then you can be able to go on to your iExcel and to your other work about that. Okay? Feel free to ask any questions and raise your hand. Thank you very much.